Alright class, in this video we're going to tackle exponential and logarithmic equations. I'm going to try to fit about 6 equations into this video, so we'll see if that works or not. First we start with the basic ones, okay? Ones where it's just inverse operation and you're done. So 2 to the x equals 7, that's an exponential function equals number, and all you need to do is do the inverse operation. So we're going to say log base 2 of 2 to the x equals log base 2 of 7. And log base 2 of 2 to the x, we know because of the inverse properties, that's just x. So x is equal to log base 2 of 7. And that's just a number. You can do it on the calculator if you like, but that's it. Okay, second one. We do the other operation, so we're going to use the exponential function. So we're going to say 3 raised to the log base 3 of x is the same thing as 3 raised to the 2. Make sure you get the exponent and base in the right place. Okay, so these just cancel off when we get x, and then 3 squared is 9. Okay. Alright, let's do one that's a little bit more complicated, but I'm only going to do a logarithm one here, and I'll talk about the exponential one. So this was where you'd have like a linear combination of these two guys. Log of x minus 3 plus 2 equals 4. Okay, so you could do the same thing with an exponential function, have some kind of linear transformation here, one on the outside and so forth. And basically what you need to do is solve for either the exponential or log equation, or log term. So that means first thing I need to do is subtract 2 from both sides. And I would get log of x minus 3 equals 2. Then I've got log equals number now, so I'd use the appropriate inverse function, which is 10 to the x. So 10 to the log base 10 of x minus 3 is just x minus 3, and then 10 squared is 100. Okay, and then we add 3 and we're done. Okay. We also have, what if we have exponential functions but they're mixed together? Okay, so I'm going to show you one way to do this. I'll explain another way. So you can you can get all the exponential stuff on one side. For example, you could move the 2 to the x, you could divide both sides by 2 to the x, and then you could rewrite it as 5 over 2 to the x, and you can think about it just like we thought of example number 1. But we can also do this. I have different bases, so I'm going to use my favorite log, and my favorite log is a natural log. Yours should be too, but I don't know if it is yet. And then I'm just going to use log properties, and it's going to be a little bit long, but it's actually simple. Okay? So using the property number 1, we get log 3 plus natural log of 2 to the x, and we get log 4 plus natural log of 5 to the x. And then using property 2, we can bring those x's down in front. So we get log 3 plus x log 2 equals log 4 plus x log 5. This is actually a linear equation with x terms on both sides. So we move, I don't know, this one to this side. We move this guy to that side and this guy to this side. And we have x ln 2 minus x ln 5 equals ln 4 minus ln 3. Both of them have an x in there. So you factor the x out. And then you divide by your coefficient, which is this complicated thing here. So x is equal to log 4 minus log 3 over log 2 minus log 5. Okay? And you can combine those. You can make that a fancy log if you want. Doesn't really matter. Okay, I also want to do a logarithmic, kind of a complicated logarithmic equation. Not that bad. Okay. So looking at this equation, what's the first thing you need to do? You need to combine the logs using the log properties so that you only have one log on each side. Okay, so I'm going to combine these logs, and the way I do that is with multiplication. So this would be the log of x times x minus 3 equals 1. And now I use my exponential function, which is base 10. I'm going to multiply that out as I go. So that's going to be x squared minus 3x equals 10. Okay, so I should say, don't leave it as x times x minus 3 and set both parts equal to 10. There is no 10 product property. There's a 0 product property, not a 10 product property. So this is a quadratic equation. You need to make it equal to 0. So you're looking for factors of 10 that are different by 3, which is 5 and 2. I think it's going to be minus 5 and plus 2. Okay, and these are, so we would go from there to say that the answer is x equals 5 and negative 2. Great, except for this is a log equation, and logs they have a domain that's only numbers that are bigger than or equal to 0. And so you need to always go back and check your answers to see which ones make sense. If I plug 5 into here, am I always taking a log of a positive number? Yeah. 5 minus 3 is 2, so that's fine. But if I plug negative 2 in, that's bad there and there. So negative 2 is an extraneous answer, and we need to chop it off. Okay? And I've got one more, and then we're going to call it a day with exponential stuff. Okay, this is what we call quadratic form, as you'll see again with trig functions. So I'm going to do a little substitution. I'm going to let y equal e to the x, then y squared is e to the x squared, and remember how the exponents work. That's e to the 2x, because you multiply the exponents. So that means e to the 2x is y squared, and then minus y minus 6, and then I use all my powers of factorization. So factors of 6 that are different by 1, so that's minus 3 plus 2. So that means y equals negative 2, or y equals 3. Okay, don't forget, we're not solving for y, we're solving for x. Y was e to the x, so e to the x equals negative 2, or e to the x equals 3. Yay, exponential functions are never negative. Their range is all positive numbers, so no solution for that. And also, you can try to take logs. Log of negative 2 is not defined. But here, we would do the natural log of both sides. We would get x equals the natural log of 3, and that is my one answer that is correct for this one. All right.